quick start with my presentation, and I'll try to introduce you into glycans, because I think the glycans are the ultimate layer of molecular complexity. Practically every protein which has been invented after the appearance of multicellular life is glycosylated. So it's composed of a polypeptide part, which we see gray in here, and some glycan components. And these glycan components are important structural part of the molecule, and one of the best examples is IgG, because we know that these glycan parts of IgG practically determine to which Fc receptor these immunoglobulins will bind. Problem with glycans is that they are complicated. We have 20 amino acids. We have approximately 20,000 glycan blocks, which can be added to glycoproteins. So the complexity of glycoproteome is tremendous. And to make things even worse, there are no genes which define individual glycans. Instead of having an individual gene which defines a polypeptide, glycans are encoded in dozens of genes, and they're actually inherited as a complex trait. So through a series of GWAS papers in the last decades, for example, for IgG, we show that there is 40 plus genes which makes a decision which kind of glycan will be added to the immunoglobulin. And these genes are highly pleiotropic for multiple inflammatory and autoimmune and some other diseases. Unfortunately, the majority of scientific community is ignoring glycans. And maybe I think one of the best examples was the blog prepared by the Francis Collins, who showed the S-glycoprotein of the COVID as a non-glycosylated protein. And actually the real S-glycoprotein looks like this. It has many glycans. And when you include the conformational dynamics, then it looks like this bottom part of the image. So practically the protein is completely covered with glycans, and this significantly affects its function. Things which make glycan even more interesting is that they're not fixed. So contrary to proteins, which they stay the same for our entire life, glycans change, because all these genes which encode them are also other epigenetic influence, and also there are some direct environmental influence. So for example, when you think about IgG, we have multiple genes regulating its glycosylation, all the epigenetic regulation of these genes, environmental effects, and we see changes in IgG glycan with time. For example, young people would have mostly glycan like this, which are actually suppressing inflammation, while older people have more and more glycans which look like this, which actually promote inflammation. So glycomics is difficult. It's not easy to analyze even a single glycoprotein. To do high throughput studies is even more difficult. And there are only a couple of labs which can do it globally. My lab is one of these labs, and we have already analyzed over 100,000 people. And we didn't analyze any 100,000 people. We analyzed 100,000 people from some of the best phenotype and genotype cohorts in the world. So most of our people where we have glycans will have a genetic data, even the whole genome data, microbiome, metabolome, epigenome, many data. So we are combining all this together, trying to understand what are these glycans actually doing. And one of the first things we learned, they highly associate with age. So if you try to predict chronological age from only IgG glycan, we can guess it plus minus 9 years. So this is not something special. So guessing plus minus 9 years is not too accurate. Methylation can be 1 year accurate. But this is actually more fun than methylation, because the delta between the glycan age and the real chronological age can be explained with many things which are associated with aging and unhealthy life. For example, they associate with all biomarkers of unhealthy life, and also a number of different diseases. And in the bottom slide, this is the effect of aging on different glycans. And these here are multiple different diseases. So glycans are not a biomarker of a specific disease. They are biomarkers of some kind of processes which happen, but which underlie many different diseases. And one of these things is the regulation of low-grade chronic inflammation. And we published a number of papers in prominent journals showing this. Even more interesting, the changes in glycans usually happen before the disease onset. So they are not only biomarkers, they're functional effectors contributing to the disease, and there's also multiple independent evidence confirming their functional role. The part which I added later in the last 2 minutes was a study which is actually not published yet. It's posted on bioRxiv. I hope the Nature Communication will publish it with them over a year. And this is showing the correlation between the glycan and expected lifespan of people in different countries. So it does seem to associate quite well with expected lifespan of a person. The most interesting thing about glycans is we can change them. So there was this very famous study about the change in methylation age. We have published 2 small studies about the change in the glycan age, which you can actually change it with simple interventions like change in activity. And we just posted in medRxiv last Friday, I think, a large study on over 2,000 twins analyzed over 20 years in multiple time points, showing that actually with gaining or losing weight, your biological age goes up or down. So really you can modify it with your lifestyle intervention. So our current stage with the glycan biomarkers is that we have something already on the market as a glycan age biomarker, which we sell. We think it's measuring more the immune age because it's analyzing IgG glycan, which is regulating multiple aspects of immunity. And the idea is that normally people go to hospital when they are ill, so they have symptoms which are then very hard to revert. Idea of modern medicine is trying to find them quickly, give them reprogramming therapy and return them to the healthy status. Our idea is let's find them even earlier. Let's find them here. Let's find them before any symptoms of a disease, just when the molecules are showing this wrong direction of disease developing, and then with lifestyle intervention actually correct it. So
there's 1 minute left, sorry.
Thank you, I'm just finishing. So this is something which we showed is doable, and we are extremely interested in doing these glycans in many intervention studies, which actually we're already doing with some of you on the call. The next thing in a pipeline is something which I call now, it's still on the market, not on the market, a metabolic glycan age, because we know that another aspect of glycosylation, which is more linked to branching, is more linked to obesity and the diabetes development. And also we think it's very relevant for COVID. So we are currently setting up a large couple thousand people study of different severities of COVID globally. And I will stop here, and I hope sometime there will be some options.